is the fourth unit, asynchronous sequential circuits. The source outcome of this unit is we are going to design and analyze the asynchronous sequential circuits. So in third unit we discussed about the synchronous sequential circuits, right? So we derived the excitation table, then we found the Boolean expression, then using that we found design the sequential circuit. In similar way we did this for the asynchronous sequential circuits. Then see in synchronous sequential circuits, the clock pulse is applied, the output changes from 0 to 1. So depending upon the given clock pulse, the output changes. But in asynchronous sequential circuits, depending upon the change in input variable, the output change. Another input வந்து x1 citizen. So this is the input, this x1 and x2, right? So depending upon the change in input variable, the output changes. So if we are changing the x1 to 1 and x2 to 0, then again we are changing. This is x1 and x2, right? So again we are changing x2 to 1, right? So depending upon the change in input variable, the output changes. So in asynchronous sequential circuits, depending upon the input variable, the output changes. So there is no need of clock pulse, right? So this is the block diagram. So this is the combination of logic circuit. We are having a feedback path, right? So in this feedback path, we are using a unclocked flip-flops or delay element, not so instead of memory element, we are using flip-flops as synchronous sequential circuits, right? So in asynchronous sequential circuits, instead of flip-flops, we are using unclocked flip-flops or latches or delay elements, right? So when an input is given, there will be some delay, right? So the delay is called as propagation delay. So input கொடுக்கும்போது கொஞ்சம் ஸ்டேட்ஸ் வந்து ஸ்டேபிளா இருக்காது. ஸ்டேபிள் கண்டிஷன்ஸ் ஆகிற வரைக்கும் அந்த ஸ்டேட்ஸ் எல்லாம் சேஞ்ச் ஆகிட்டே இருக்கும். ஃபாலோயிங் எக்ஸாம்பிள்ஸ்ல பார்ப்போம். So there will be some delay that is called as propagation delay. Then in this x1, x2, x3 will be the n inputs. These are the inputs and z1, z2, n will be the outputs. Here we have n number of outputs. Then this one will be the feedback path, right? So listen, this y1, y2, y3 are called as present state or secondary variables, right? So present state of the feedback வந்து என்ன சொல்லுவோம்? Present state or secondary variables. Then the output we are getting in the next is called as excitation variables. So y1, y2 and y3 are called as excitation variables or next state variables, right? So the feedback given in the input side is called as secondary variables and variables present in the output side are called as excitation variables. Then citizen. So small y1 will be the present state variable and capital y1 will be the next state variable, right? So when the system on the stable work ஆகணும்னா it should satisfy the following condition. So it should satisfy small yi equal to capital yi, right? So கொடுத்த input வந்து outputல வந்துரும். So the condition will be small yi equal to capital yi. So if the system satisfies the following condition, then the system is said to be stable. So for an unstable condition, what is the equation path? For an unstable condition, small y is not equal to capital Y, right? So we can see this by using the following examples. Then in this asynchronous sequential circuits, so we will be changing our output, right? Consider this. X value change from 0 to 1 and y1, y2 values 0, 0, 0, 1, 1, 0 and 1, 1, right? So in this asynchronous sequential circuits, at a time you have to change any one input variables, right? So at a time when the input variables are changed பண்ணக்கூடாது. ஏதாவது ஒரு input variable change பண்ணணும். For example, this is 0, right? So consider this as y1, y2. So at a time we can change only one input variable. First we can change 0. So 0 moves to 1 and 0. Again, this is y1 and this is y2. Then we have changed the y1. Then we are going to change y2. Right? So that will be the 0 will be the present state and 1 will be the next state. So at the same time, we have to change only one input variable. If you are changing more than one variables at a time, what happens? If you are changing more than one variables at a time, what happens? The system becomes unstable, right? So for a stable condition, you have to change only one input variable at a time, and the system should satisfy the above condition. Pulse mode, right? So when you are changing the input variable, right? So there will be some changes in the circuit. So until it reaches the stable state, stable state reach state change, right? So we discussing about that in the fundamental mode operation. So we discussing the analyze procedure of asynchronous sequential circuit. This will be the circuit, right? So here y1, y2 will be the inputs and capital y1, y2 will be the outputs. Then what is the output equation? So we are doing the analyze procedure in the reverse. So in synchronous sequential circuit, this is the last diagram, right? So we are doing the procedure in reverse. So what is the output y1? So x into y1 plus x dash into y2. So that is the output equation for y1. Then what is the output equation for y2? X into y1 dash plus x dash into y2, right? So we have got the output values for y1 and y2. Then listen. So we are going to map the values for y1 and y2. So listen. Now we are going to map the values for y1 and y2 in the K map. So consider this is the K map. This is for y1. So this is for capital y1 and this is for capital y2. Right? So x will be the inputs and k is for 0 to 1. 2 possible conditions 0, 1. And for y1 and y2, what are possible conditions for 0, 0, 0, 1, 1, 0 and 1, 1. Now substitute. So consider this equation. Substitute x as 0, y1, y2 as 0, 0. Substitute in this equation. Getting the answer of y1 as 0. Right? Consider this equation. y1 is equal to x into y1 plus x dash into y2. Right? So substitute. Value for x as 0, 0. Then what is value of y1 and y2? 0. So we are getting 0. Right? Any doubts? So we are going to map the values for y1 is K map. Then we have to substitute x as 1, y1 and y2 as 0, 0. We are getting 0. So in this equation, we have to substitute the values and getting the stable. Is that clear? Any doubts? So instead of x, we have to substitute this value. Then instead of y1 and y2, we have to substitute this value. Right? So we are getting the gamma for y1. Then for y2, we have to use this equation. Right? So in that, we have to substitute the value for x as 0. Then y1, y2, 0, 0. The next, y1, y2, 0, 1 and x 0. Like this, we have to do this. Right? Then we are going to form the transition table. Transition table is nothing but we are going to plug the two values of y1 and y2 in a single table. So transition table is nothing but plugging the values of y1, y2 in a single table. When you take the values set to one table putting the transition table, right? So in sequential circuits, we will derive the excitation table, right? Similar, we are going to derive transition table then flow table, right? So listen. So this is the value of x 0 and 1 and this is the value of y1 and y2. So 0, 0, 0, 0, right? Then 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, then 1, 0, 1, 0, right? So you have to plug the values of y1 and y2 in a single table. Next, 0 is the present state. What next state comes? 0, 0, right? So listen. See, y1 and y2 value is 0, 0, right? And this is the next state. What is the capital y1? 0, 0. So the condition is satisfied, right? So here, y1 value is equal to capital Y value, right? So the system is stable. So in the input கொடுக்கிறோம்ப்பா அது அவுட்புட் எக்ஸைட் ஆகும் right so the system will be stable so stable state a round one circle one circle end circle the stable state then remaining 0 what is the unstable state again to move back to the input right then we are having 0 what as the present state and 0 will be the next state. So this will be the stable state in circle back. Then again this 1 1 is an unstable state and moves again back to the present state. Then here we are having 1 1 right. So in circle back. Then 1 0 will be the unstable state. Again it will move back here. Then 1 0 is the stable state. 0 0 will be the unstable state. Stable state ஆகிறது வரைக்கும் இந்த process continue ஆயிட்டே இருக்கும். புரியுதா? Right? So if you are giving a given input yi, you should get the same output. Then the condition will be the system will be stable. Right? So stable ஆகிற வரைக்கும் the procedure repeat ஆயிடும். Right? Then see in the transition table you should contain only one stable state in a row in each row. ஒவ்வொரு ரோலையும் ஒரே ஒரு stable state இருக்கணும். Then it is referred to as primitive state row. Right? So completed by this. After this, any doubts? So we are doing the process in reverse. So first we find the output values of y1 and y2. Then using that relation we will be marking the values for y1 and y2. Then we will be plugging both the values in a single table, that is the transition table. Right? Then we will be encircling the stable states. Stable are